Hello, thanks for joining us for our latest video. I'm Alex Toohey, Technical Solution Manager with Element, and today I'm joined by Ken Anderson.
Yep, Technical Manager for EMC.
And so we're filming this mid-July, which means two things. One, the World Cup is on, so congratulations or condolences to England on their victory or defeat against Norway tomorrow. And also it means it's a heat wave. As you can see, I've got my short sleeves on, but Ken, as well as having an illustrious career in EMC, also moonlights as a suit model in and around Hull. So we're obviously thrilled to have you with us in your suit today, Ken.
Yeah, thank you very much, Alex.
No worries. Okay, so we are here today to talk about some topics that don't really get discussed particularly often, but are quite important. So Ken and I, we both have a background in EMC and RF side of things. So what we'll be talking through today is some common issues with EMC testing, or issues, maybe it's not the quite the right word, but misunderstandings.
Yeah, exactly. Misunderstandings are more the
Yeah. And we'll be talking through things like harmonized standards, performance criteria, things that people should really understand but don't really get the discussion they deserve, I think. So why don't we kick off with harmonized standards? And I suppose first we need to define that term, really, because we throw it around quite often because this is our bread and butter. But what is a harmonized standard, Ken?
Well, basically the harmonized standard has got two main criteria behind it. The first is that it has to be produced by one of the three standardization bodies within Europe. That is CEN for non-electrical standards, Senelec, which is for electrotechnical standards, basically most electrical equipment. And then there is ETSI, which is specifically for radio and telecoms based equipment. So basically they can either adopt an international standard or produce their own standards. That's the first stage of a harmonized standard. The second important thing is for a harmonized standard is that they have to be published within the official journal of the European Union. Without that, they are just a European standard, but they are not a harmonized European standard.
And despite that, we often see standards with the word harmonized in the title, don't we? Because these standardization bodies assume they will become harmonized at some point.
Yeah, and that's often where the problem is, especially now after a court ruling. The European Commission are getting rather hot on ensuring that there is legal certainty within standards, and this is an interesting topic on the grounds that we as technical people look at standards as being technically robust, but that whole idea of harmonization is it goes above technical robustness, and it's also got legal robustness to go with it. There is a certainty, a legal certainty, that standard gives you what is referred to as presumption of conformity.
Yeah, and this legal case that Ken was referring to there, the James Elliott case, is it really marks a step change, I suppose, in how the Commission treat these harmonised standards, doesn't it? Because before then, you could have a standard with potentially multiple methods to assess the same criteria, but now that's being tightened up, isn't it?
Yes, they like to prefer to get a standardised method unless it can be verified that the two methods have basically will give you the same outcome. There is that, so and that's where the legal certainty part comes in. They we as technical people may think that a standard the methods in the standard will give you equivalence, but that will get further rigor and questions asked: is this true equivalence?
Yeah, so you might hear conversation at the minute about the differences between a FAR and a SAC for radio testing, for example, because a lot of the radio standards are being updated to limit the assessment methods you can use there, and there's a big discussion about whether they are equivalent. So Ken, just to recap then, the process is that the European Commission will send a request to these ESOs, the standardization organizations, saying, we would like some standards to address these requirements from a piece of legislation, whether it's the RED or the EMC directive. The ESOs will write the standard, submit that back to the Commission, and then they check it themselves, or do they outsource bits of it? And how does it then get listed on the journal?
Basically, the Commission tend to employ external consultants who, as well as having a technical background, have a legal background, so that they can look at it from a legal standpoint of how robust that standard would be if a manufacturer had to rely on it in a legal sense. If a product manufacturer was taken to court and they said, we've used this standard, it's a harmonised standard, sort of, why are you sort of taking us to court? The standard has got to be able to stand up to legal scrutiny, and that's why there's been such a backlog of standards that have been, have been technically approved, but they haven't been placed in the official journal.
Yeah, okay. And I suppose the converse is true once a standard gets towards the end of its life as well, because that might be revised by the standards writing body, but the old one still exists on the journal, the new one's not added. How do manufacturers address this?
On a strictly legal basis, the only version that can be used as a harmonised standard is the one that is in the official journal. But that does not necessarily mean that you cannot use later standards. The harmonised standard gives you presumption of conformity, but presumption of conformity is not the only route. If you can demonstrate conformity against the various articles of the EMC and radio directives, that is a valid route to go. So you're looking at the basic sort of requirements of the directives. If they've been met, you're fine. There is no need to use a harmonised standard. It's just that harmonised standard gives you the easy sort of presumption of conformity route, rather than you having to justify why you've used that alternate standard.
Yeah, and this becomes more important for radio products compared to non-radio products, because the choice of standard can have an impact on the different conformity assessment procedures you can take, can't it?
Yes, that's certainly, yeah. And obviously, there is also, you get into the realms of whether you need to involve a notified body as part of the process as well. That tends to be less of an issue within EMC, sort of, but certainly, within the radio side, obviously because of the implications of interference of equipment is much more likely with an intentionally radiating piece of equipment. There is a tendency that that the requirements are a lot more rigid in how they're applied.
Yeah, of course, that makes sense. And then so a manufacturer presented with having an old version of the standard on the official journal and the newer version of the standard published. Is it possible for them to, say, test to both versions, list both on the declaration, or to carry out some sort of analysis between the two and just cover a gap test?
Any of them approaches can be used. Obviously, the watertight case is to test to the harmonised standard, and and then to test to the new standard. But providing you've got a robust gap analysis between the two versions, you may find that the new version is simply the old version, but there's some additional requirements, in which case you can test to the new version because the old requirements are identical to what was in the version that's in the official journal. You test to the newer version, and you produce that gap analysis to support it. The extra work is that you've just got to do the hard yards to sort of to show that the standard that you're using has got the sort of the same weight as a standard that has been published, that is published in the official journal and is harmonised.
Yeah, but I suppose it's very rare that a product would meet a new version of the standard and would be unable to meet the older version. There's generally not conflicting requirements between different versions.
No, not unless there is a case sometimes that happens, and this just happens because technology moves on, that a new standard decides to take out a requirement for a reason. It's decided that it's no longer relevant, but technically the harmonised standard still has that test in it, so you would probably need to look at that there. You still need to sort of look at the the requirements of the harmonised standard, but basically the requirements it's meeting the essential requirements of the directive that is the main issue. That is the default position. Whether you used a harmonised standard or not, it's meeting the essential requirements of the directive that is what allows you to place your product on the market.
Yeah, so the standards are not the law, but the directives obviously are the law. So when a manufacturer places that product on the market, they have to issue that declaration, that promise that they meet what the legislation tells them to.
Well,
having used the standard is just an easy way to demonstrate that.
Yes, that's correct. Yeah, the declaration is always to the directive. You may list the standards on your declaration of conformity as proof that you've met the essential requirements of the directive, but the declaration is always to the essential requirements of the directive because, as you say, the directives are the law. The standards are not the law, although they need to be, legally robust enough to stand up if they're used as evidence to support you meeting the essential requirements of the directive.
Yeah, and I think if you look in the annexes of most of these harmonised standards, you'll see wording that says this is one voluntary means of meeting the requirements in the directive.
Yes, that's very much the case.
Yeah. So we've talked a lot then about standards and testing to these standards. We're a little bit biased, obviously, working for a testing laboratory. What's the role of a test lab in all of this?
I think there's two main roles as I see this. Is that one is obviously testing to the standards and applying the standards correctly, there. But we also, to a point, and certainly within certain parts of the company, there is the advisory side of advising clients of the best approach to use for demonstrating compliance to the directives, because it's not always straightforward. And having people who've worked with these for a number of years, it's obviously there's great experience within test labs, and that's something you should always look for. Basically, with a test lab, is someone who can advise you of the approach to get your products onto the market, because that's that's the aim of all of us. We're here to help you get your products on the market.
Yeah, and I suppose that knowledge and experience becomes particularly useful when we have the situation of a newer version compared to an older harmonised standard, carrying out that gap analysis to find a pragmatic set of tests to do to satisfy both.
Yes, certainly. As my role as technical manager, I do an awful lot of gap analysis between old and new versions for our own purposes. But that knowledge, we're happy to to pass on to clients to help them get their products through the process. If we've already done the hard yards on that's knowledge that we're quite happy to pass on.
Yeah, and where does accreditation come into this? Because we are, of course, a UKAS accredited test laboratory.
Yeah.
Does that make a significant difference to manufacturers choosing a lab?
It certainly helps them gain a lot of confidence, because we're assessed and we have to demonstrate that we've got the competence and the capabilities to be able to perform this testing. Now, that's not to say that unaccredited labs are necessarily bad. That's not the case, but it gives you that extra assurance that that a laboratory has been regularly audited against the requirements of the standard, and can perform that to a known standard.
Yeah, and we see a lot of manufacturers coming to us at a later stage in the process, having already done some early pre-compliance type testing, potentially with an unaccredited laboratory, but then using the accredited lab for the final test report they'll use to sign off on their DOC is quite helpful.
Yeah, yes, most certainly. And as I say, certainly a good non-accredited lab is always a good tool, if that's convenient for you. I think the important thing is that even if you're picking a non-accredited lab, you would want a lab that works to an almost accredited standard. There are certain testing that we do that we've chosen not to be accredited for, but we still apply the same processes of accreditation as what we for non-accredited work as what we do for accredited work.
Yeah. And we're talking really about a lot of European standards here and the European approach. But when we look at North America, for example, choosing an accredited lab isn't just optional; it's mandatory to fulfil that certification.
Yes, it is. Yeah, and under the present FCC regime, especially with their present obsession with bad laboratories. Sort of, it's something that manufacturers need to be really careful about who they choose to partner with.
Yeah, I am sure at some point soon, Ken, we'll be doing another video like this talking specifically about the FCC and their campaign against bad labs. But for now, we'll keep off that topic.
Yeah.
But on the subject of certification, we touched on notified bodies earlier and when they might be needed. Can you just explain why and when a notified body would be needed and what role they play?
Basically, sort of as far as the EMC directive goes, there is no compulsion to use a notified body, even if you're straying off the path of harmonised standards. It's seen as less of a risk than what radio sort of testing is. But as soon as you start going off the harmonised standards route for radio testing, that's when you're starting to get into the territory of having to use the services of a notified body, and their role is really to ensure that the process that you're adopting is the correct sort of process, and to as well as advise, but also to give that final check, sort of to ensure that you are applying the right standards so that you meet the essential requirements of the directive. I know I keep banging on about this, but the essential requirements of the directive is always the goal you should be looking for.
Yes, I suppose the downside is that those essential requirements are always quite vague in the legislation. And that's not a criticism, that's just how the European process is written, the requirements.
But that's where a good notified body comes in, because they have got the experience to interpret them essential requirements and put that into what does that mean as far as what testing you need to do, what criteria you need sort of for your equipment, and whether they feel that your equipment does meet the essential requirements, and that can only come with an experienced notified body.
Okay, and then how about Brexit? So we talked about notified bodies as a European thing, and obviously the UK used to be part of the EU. How did things change, not just for notified bodies, but for CE marking in general when the UK left the EU?
I think the biggest change is that notified bodies are a European institution. So no longer being sort of part of the European Union, sort of obviously all of the UK sort of notified bodies ceased to be notified bodies. However, a lot of them stayed on under the UK scheme, sort of under a very, very similar role, sort of under the UKCA scheme, sort of. But as far as legal standing with the sort of the European Union, you have to be a European Union sort of member country sort of to have official notified bodies.
Yeah.
So obviously, sort of if you've got a multi-country sort of organisation, you're fine. But if you're a single UK entity, sort of obviously that's something that is no longer open to you as a company.
Yeah, so of course we managed to get through this by having offices in the US and in the Netherlands who have notified body functions already. So we seconded a lot of staff to those organisations to get through it. But I imagine it was difficult for purely UK notified bodies who can be a UK approved body now, but not an NB for Europe.
Yes, that's pretty much it. And it's hit sort of particularly hard, I think, some of the smaller organisations and ones that are basically one or two man consultancy companies who set up as notified bodies and no longer have that facility. So another advantage of using a larger organisation that has that facilities to be able to provide notified body services.
Yeah. Well, let's move back from sort of geopolitics for a moment and think more about standards, which is our bread and butter.
Yeah.
In particular, performance criteria. So this is the impact of that James Elliott case we were talking about earlier in the legal certainty is that performance criteria for EMC testing standards have had to be narrowed or at least been made more prescriptive. How has that affected some of the more recent standards we've seen?
I think sort of certainly with regard to it, we're seeing a lot more, how would you say, it's a lot more sort of prescriptive type of performance criteria and a lot more tailored to individual types of equipment. There's a lot more words in the standards nowadays. And where there was previously sort of vague things that grouped equipment together, now there tends to be, for specific types of products, there is specific types of performance criteria, which is absolutely fine if you're looking at a pure sort of non-radio product that's going for EMC testing, but it causes no end of pain sometimes where you've got a product that has been previously fell under the EMC directive, but someone's decided, oh, let's put some wireless functionality within it, and suddenly you're in a whole new game, because traditionally the EMC standards for radio, such as the EN 1489 series standards, they have had very much performance criteria that's been purely sort of for radio type products. You get things like sort of bit error rate, packet error rate as being the predominant performance criteria for determining whether a product is compliant or not. Now, when these radio products are incorporated into non-radio products, you really don't care quite so much about the pure radio link performance as so much as what you do, the overall performance of the equipment that you're doing, because EMC is very, very much a system-based test, whereas radio tends to be very much a parameter-based testing. You're trying to measure an output power, you're trying to measure a bandwidth, whereas with EMC you're looking to see, does the product still continue to operate and function properly overall.
Yeah, so if we think of a pure radio product like a garage door opener or a walkie-talkie, you could quite easily say, well, as long as that's sending 90% of packets successfully, that's fine. That's what we want it to do.
Yeah.
A pure non-radio product like a printer, you could say, well, as long as it keeps printing that paper properly, it's doing what it's supposed to do.
Yeah.
The example I've heard you give before is about a wireless crane system. So we see a lot of industrial equipment now with wireless functionality.
Yeah.
Talk us through this example.
Yeah, you've got an industrial overhead crane for a factory, and you've decided that rather than having a long umbilical cord to the controller, which they traditionally have, manufacturers have moved over to wireless controllers. They give them a lot of advantages there. But the one problem is if you looked at the performance of the remote controllers, if you looked at it from a purely radio point of view, you'd be looking at, as you say, you'd be looking at power output and you'd be looking at packet error rates of the radio link. Now, that, important as it is in the radio world, in the overall equipment world, is probably of less of an interest. You're more interested to know that if your equipment is being interfered with, does the crane suddenly go out of control? The emergency stop doesn't work. As you say, it goes out of limits. Or even worse than that, it suddenly decides to drop the item that you're busy moving along the factory floor with obvious safety concerns. So what you've got to do really is you've got to think on a system basis and think outside the basic radio parameters and consider what's the real world implications of a loss of your radio link.
Yeah, so this is a good example then of where a manufacturer might have a harmonised standard they could look at, or potentially a non-harmonised standard, but they would need to do a risk assessment for their product and say, well, actually, the test in the harmonised standard is not appropriate for our situation. So we'll come up with our own test, our own set of performance criteria, possibly then deviating from the harmonised standard. And if it was for an Article 3.2 radio spectrum issue, they'd then have to go to the notified body and say, this is what we've done, this is why we think we meet the directive. Can you please underwrite that and give me a certificate? Yes,
pretty much, yeah. Because as I said, going back to my favourite term of the essential requirements of the directives, the item has to perform as it does. You're more concerned, if you lose your radio link, that is a problem, but you're more interested to know that if you do lose your radio link, does that product sort of go into a safe mode? You know, especially the one that could be a problematic one is, you know, if taking the example of the crane, if once it does get the link, you don't really want it to be going back into a movement mode, sort of when people are not expecting it. So you'd expect it to, if it lost the link, to go into a stop mode, apply the brakes, and not move again until it's got another command.
Yeah. Good. Okay, so this is all obviously on the immunity side of things. We're looking at the performance of the products while we're applying interference to it.
Yeah.
If we think about the emissions requirements for a moment, we've almost got two or three different conflicting sets of emissions requirements, haven't we? For EMC, for radio equipment with non-radio functions, because we have the transmitter itself, and that potentially would have a transmit mode or a receive mode or a standby mode potentially. And then we've got all the emissions from the digital circuitry around it. Now, the approach in North America, or the approach in the US certainly, is to separate those two sets of emissions. How is that covered in Europe? And is this well understood? Because, well, I'm leading on to it there, but the answer is no, it's not particularly well understood, is it?
It's definitely not well understood. It hasn't been helped by standardization in the past, but I'm seeing some good signs from recent standards to do. Basically, if not to put too fine a point on it, I think the EMC world have buried their head in the sand about emissions from equipment that incorporates radio. A lot of the standards have basically said sort of, this has got a radio in it, sort of, over to you guys, the radio guys, to measure them. Sort of, we're not going to actually deal with this issue, which has caused a lot of problems. Sort of there, because you can end up with emissions, as you may well know, from the equipment, the non-radio part of the equipment, and how do you deal with that?
Yeah. So I suppose really going back to that different sets of limits, we've got when the radio is transmitting, we might have a high set of spurious emissions limits because there's an understanding that will create some noise.
Yes.
When the radio is in a receive mode, we have a stricter set of emissions limits. But historically, that receiver spurious emissions requirement was put into the standards to protect the receiver itself, wasn't it? Rather than from emissions from the equipment. But this is going back to when a radio was a radio and a printer was a printer, not when you have the two things sat on top of each other.
Yeah, and that gets you into the realms where a lot of things, especially industrial equipment that's designed for sort of emissions, to Class A sort of emissions limits, are effectively having to meet sort of Class B, much tighter sort of emission limits, just because that's what the equivalent of the radio sort of standards are calling up. And in some cases, the receiver standards are even worse than that. They're even below the what you would normally expect sort of for an EMC standard, which has caused the manufacturers an awful lot of issues.
Yep.
So one of the things I've seen of late, sort of looking at the latest version of CISPA 11, they've started to look at this issue where they've now said, fair enough, you ignore anything that's coming purely from the transmitter, but you still need to look at anything that's coming from the equipment itself, and sort of anything that is a combination, sort of, we can get interaction between emissions between radios and non-radios. Previously, that was strictly in the radio equipment side of things, but now they're saying, well, no, we're erring on the side of if there's an emission that's partially caused by the non-radio part, it's legitimate for it to be measured in the sort of the non-radio sort of equipment EMC standard.
Yep. And how about emissions that are generated from interaction of two transmitters themselves, so the intermodulation products? Is that a 3.1 EMC issue or a 3.2 radio spectrum issue?
That's really purely a 3.2 radio issue, because it's two radio products that are interacting with each other. Each of them individually would be assessed under Article 3.2. So therefore, if you've got intermodulation caused by them, that would still stay within the 3.2 arena.
Yeah. Okay, so while we're talking about the 3.2 emissions and the radio spectrum side of things, there have been some changes to the radio standards recently as well to add in these environmental profiles, haven't there? Because if you look in older versions of the standards, it will potentially give you some guidance on what to choose, but it leaves it very much up to the manufacturer, which isn't in line with this legal certainty we've been talking about. So how are things changing there?
Basically, as you say, there is this environmental side of it. It's not a side I've looked an awful lot on, sort of on the EMC side, because we are tied by sort of our environmental conditions, anyways, for a lot of the tests. But I know certainly, and from my own experience of doing radio testing in the past, the environmental sort of conditions do have a big impact on the sort of on the results that you can get. So obviously that is going to be a big thing going forward, and it's certainly something that we as a company are sort of looking seriously at.
Yeah, I suppose the message right now though is just watch this space, because we're only just seeing it start to make its way into standards, and we're only just starting to see market surveillance bodies say they will be doing something about this. And there is still an open question over if you have a temperature range which is narrower or wider than the ones in the standards, what do you do in either of those cases? Jury's still out, I suppose, on what the industry will do long term there.
There's speaking to some experts on the subject. There's two groups of thought. There's the complete sort of safety first approach, that you have to test everything at the widest possible thing between what the standard calls and what your product calls up. And then there's what you might call the more pragmatic approach, where you don't go beyond what either of them say, basically.
Yeah, but the bottom line really is the manufacturer, and this really underscores everything we've been saying for the last 15 minutes. So the manufacturer should do a risk assessment to identify what set of tests they need to do, whether that's drawing from harmonised standards, other specifications, what performance criteria they use, what environmental profiles. And then if they need to, go and get a notified body to assess that and make sure it's right. And if they need guidance on coming up with that risk assessment, well, there are outfits out there like ours who can help with that.
Yeah, and as I say, it all comes back to, as I keep banging on about, sort of its essential requirements, and that forms part of your essential requirements.
Well, thanks, Ken. This has been really enlightening. Hopefully it's been useful for you all watching as well. We will be doing more of these sessions over the coming weeks and months, so do please look out for more of those. You can follow us on LinkedIn and subscribe to our YouTube channel. I'm sure there will be links below this video somewhere. Thanks for watching. Thanks, Ken.
Thank you.